And a hearty welcome to everybody who's joining us, especially if you're joining for the first time, if you're looking into the techniques and technologies of Cisco systems, including those focused on CCNA, you're in the right place. My name is Keith Barker. It's great to have you here. I happen to be a double CCIA. I've been working with Cisco gear for probably 15, 16, 17 years or so, and I love it. So the purpose of this channel and these videos that we're creating lately is to help people at the CCNA level get that leg up they need to get the CCNA done, get the understanding, and then keep on their journey in the world of IT. All right, so it's great to have you. A couple weeks, about somewhere between 2 weeks and 3 weeks ago, we had a video on how to connect your home lab to the internet from your home. So it's a lot of fun, and I had some surprises in that came up. That I go, why is that? So we walked through that, and I thought to myself, you know what? For people who don't have a home lab, like a whole bunch of their home router with their DSL or cable modem, whatever it is, and then their home network, and then a whole nother network with Cisco gear that they can connect to the internet. I want you to have that same experience of doing it, though, because when you're on your home network and you have this whole separate routed switched infrastructure with Cisco gear, switches and routers and VLANs and everything else, and those devices actually have access through your home network to the internet, it's amazing. I still get a rush. I mean, when I have that's connecting to the internet from my home network in my home lab. So what I did was I created a packet tracer lab that simulates that whole environment. And so what we're going to do in this lab is I'd like you to download the framework for it. And the goal is to get this lab connected to the internet. And it's all contained within Packet Tracer. So if you don't own one single item of gear, you can still practice with this. And because we had a lot of really positive feedback on things like, wireless LAN controllers and other devices in a network, I've also included some of those too. Let me, first of all, show you how you can get the lab, and then I will walk you through the tasks. And then if you want to continue, I'll walk you through the solution of how to implement full connectivity from a home lab up to the internet. All right, let's take a look at the download. So this is the download page for thekeithbarker.com. So if you go there to thekeithbarker.com and scroll down a ways, there's downloads. I also had some great feedback regarding, hey Keith, let's rename your labs in your download section. I thought to myself, that is a great idea. I appreciate that. And so I had labeled these based on the dates I created them. And if you just look at those, like, what is that lab and what's that lab? So now, and I'll go back and I'll retrofit some of the other ones as well. This is the current lab. It is Simulate Home Lab to Internet Connectivity. And I also put the date there, so I can also have that as a marker as well. So this is the lab we're going to download. And what I'm going to do is I'm going to download this right now with you, and that way I'll be working on the same exact lab topology that you are. Another thing to be aware of is that we are using, or I'm using, let me change my screen back. It's like, whoa, you hit a weird button. What happened there? Excuse me on that. I'm going to be using Packet Tracer version 7.3. So make sure you have at least that version or higher if you want to open this up. And let me get rid of that pen. All right, so I'm going to download this, and I'm going to save it. I can't wait to go back and see what that looks like afterwards with that weird button I pushed. Okay, so I've downloaded it. Let me go to my downloads folder. Here it is. That's one I just downloaded. And if I scooch this over a little bit, it's the OGIT PT Home Lab to Internet Sim, and then the date. 2004 and the 18. I'll add that later. All right, so I'm going to open that up. Actually, let me extract it. Let me go back one folder. Let me extract that. And there it is. All right, and then I'm just going to go ahead and open it up. So here is the PDF with the instructions. And I also put these instructions right in the lab itself. All right, so I've already authenticated in Packet Tracer, so Cisco knows who I am, and they're not going to ask me to authenticate again. If you're opening up Packet Tracer the first time, sometimes you have to re-authenticate, and that's okay too. So let me size this up. Almost there. Oh man, I had so much fun putting this together. Let me give you a little insight on it too. So I was talking to, there's a lot of amazing people helping out on the Discord server and for the channel for questions. And there's a lot of them, so I don't want to leave anybody out. And I appreciate all the help. People who are beyond CCNA, but they want to come back, and a lot of them help other people who are learning CCNA. It's fantastic. And one of those individuals is Kelvin. And Kelvin, I asked him, hey, what do you think we should do for the next lab? And he goes, why don't you do dynamic ARP inspection and DHCP snooping. I said, great. And yesterday, I labbed it all up, and it doesn't work right in Packet Tracer. It does not behave. Most of the time, Packet Tracer does a great job. But as of today or yesterday, and the current version of Packet Tracer I'm using, the DHCP snooping and the associated ARP inspection wasn't working as it should have. So I built this lab. It didn't function. I thought, I'll just wait. I'll do that one later for a Packet Tracer lab when everything's working. So thank you, Kelvin, for the idea. And it didn't pan out because it wasn't working correctly. All right, let me scroll down. Woo, look at that. This is kind of small. Let me let me make it bigger so we can read it. Let me do this. It looked bigger on a big screen. So just for the presentation, let me size this down a little bit. So what we have cooking here is this is very similar. In fact, let me go back to this for a moment. This is very similar to the lab we did where I placed my home gear and gave it internet access. So here's the play-by-play for the physical infrastructure. And if you want to go back and look at the video on connecting a home lab for Cisco up to the internet, it uses this topology. And what I have is I have a cable/DSL modem. In my house, it's cable. And then I have a home router. And this is my network 192.168.1.0. The router is a default gateway address of .1. I have a PC here. And then I put router 1. This is the beginning of my home lab over here on the left. And I had 00 going to the right and 01 going to the left. And then I had a switched virtual interface on this multi-layer switch and some other VLANs out here that I could support. And it was great. And to get it all working, I wanted to have my whole home lab be able to go out to the live internet, have full reachability for IP addressing and also possibly DNS resolution if I wanted to. And so I thought, that's what I did in this Packet Tracer lab. I recreated this all inside of Packet Tracer. So all you have to do is just download the Packet Tracer lab. Then we just downloaded together. And not only can you work through the scenario of getting your home lab connected to the internet in the Packet Tracer environment, but you can also have a lot of fun, which I had a lot of fun putting together in the lab portion. Let me show you what I mean. Let me minimize that. And this is just so much fun. Check this out. Let me bring back. I'm going to size this a little bit differently so we can see it all better. And I'm also going to remove my backdrop here so I can move things around and have everything shown. So I'm going to click on the backdrop and reset and apply. Great. Now it's gone. Fantastic. And let me just move this all over. And that way we can see it better. And almost there. Let me make a few more changes here, because it's important to be able to see what we're doing as well as knowing how to do it. All right, that may be as good as I get for this. That's fine. So in your environment, you can make this full screen if you want and have see all the details even more clearly. So here's what we've got. I've got a little home router and this network. So this represents my home network here, or in Packet Tracer, your home network, and it's 192.168.1.0. The default gateway is .1. I've got a wireless client, and I've got an Internet of Things device. I just dropped it there for fun. I've got a wired client. So at home, in most home networks, the little DSL/cable modem and or integrated wireless router, it has switch ports that you can connect devices to. It also has wireless, but logically, it's all that internal network right there of whatever that IP address, whatever that IP network is on the inside. And so this guy's handing out IP addresses via DHCP, handing out the default gateway of .1, handing out a DNS server. Life is good. So what I did for the internet, and I'll put this in a slightly different color, this is the whole internet. And you might say, well, Keith, I thought it was bigger. Well, the internet here is represented by one server, and that server is at 23.1.2.2. And that also is running web services. It's doing DNS services. It's going to be our little pseudo representation of the live internet. And then from right here on router 1, we have gig 00 that goes out to this home network. And we have gig 00 goes to the home network, and 01 goes to the lab. So in the lab, check this out. I've got a wireless LAN controller. If you want to play at that, it's in the lab. Have fun. A lot of times people are saying, well, I'd like to see the interface for the wireless LAN controller and how to practice with it. What you could do is just find out what the IP address is on that guy, and go to a PC, connect via HTTPS to the IP address of the wireless LAN controller. And oh, by the way, we have a separate video that we did just on the wireless LAN controller, the whole setup from soup to dessert. So check that out. It's in the master playlist for CCNA 200-301 right here on YouTube. So you can check that as well. But if you want to connect, just find out what that guy's IP address is. And you can just look at the details or hover over it. It'll show you. Connect via HTTPS://, and the username is admin. And the password is capital CISCO !23. I set that up when I set it up this morning, about 2 hours ago. In fact, I was like, well, what else could I do here? So I've got the wireless LAN controller. I've got this access point that's registered to the wireless LAN controller. I've got this internal lab server for our home lab, and it's got DHCP services on it. This is just a layer 2 access switch. There's 4 VLANs. This guy is a multi-layer switch. He's got routing going on. He's the default gateway for 3 VLANs, 2, 3, and 4, and then router 1 is the default gateway for VLAN 1. So I just had a lot of fun. I was like, when I was putting this together, I thought, you know what? Here's a really good challenge. If you are already past the CCNA level and thinking, you know, I'd like to go ahead and just remind myself of how these pieces work, I would encourage you to look at this topology and set it up. Just create 4 VLANs, have the switch do routing for 3 of them, or you can actually design it any way you want to, just as long as you have full reachability route-wise, and then set up the wireless LAN controller, an access point that's associated with the wireless LAN controller, DHCP services, and routing, and set it up from scratch. It was more fun and more reminder for me than I thought it was going to be about, oh yeah, because trunking's got to be there, routing's got to be there, DHCP. I didn't need DHCP relay here because I've got, I did have to do DHCP relay because the lab server is the actual DHCP server, and I had to have IP helper on the VLAN interfaces on the multi-layer switch. So anyway, there's a whole world of happiness there waiting for you if you want to practice. But our focus here, as we stay on topic. I got a little bit excited there. Our focus here is how do we get this whole network, which by the way is working. Let me clear this off. This network here is functional, meaning everybody has the right default gateways and everybody has full IP connectivity to everything here in this lab network. And our goal is to connect this lab network and have reachability out to the internet. And what that means is every device that has a browser, so that would include the lab server here, this PC, this wireless client who's associated with an access point, who has cap-wap going on with the wireless LAN controller. Everybody who has a browser, I would like them to be able to go to the KeithBarker.com. And that's in the instructions in the lab itself as well. Now, that is a name, obviously. So, and so what happens is if these clients want to get to thekeithbarker.com, they are going to need to do a DNS request to a DNS server. And the DNS server they all believe they should be using is this guy out on the internet. So if we want DNS to work, and the DNS server's out here on the internet, we need to make sure we have reachability out to the internet and back. Now another option could be, I guess, we could retrain everybody. We could tell the DHCP server, hey, hand out the IP address of this guy as the DNS server, not this guy as the DNS server, and then create the A records here. And then they could, but you'd still, to get out to that server, if this is also the server on the internet, they could do DNS here, but they still need to go out. So those are all questions and solution and situations that we need to address, playing partly network engineer and also network troubleshooting when it's not working. So everything here is golden. It's all working internally. Our goal is to get all this connected out to the internet. And this is very much simulates what we did with the live gear in the previous video, except I've added a couple kinks. So and you'll see those when you go through the lab. So every device that has a browser should go to thekeithbarker.com, which is this little server right here. And I also want to thank Dan, Layer 1 Man, who actually created this custom web server for me in Packet Tracer. And I've just been using it over and over and over and over. So if you want to see some great videos, by the way, on splicing fiber with with a fiber optic cable splicer, check out his videos as well. And if he's sharing that publicly, I'll put a link for that in the description of this video as well. So thank you, Dan, very much for that. And I appreciate everything that's being shared on the channel and in Discord. Okay, so everybody with a stay on target, stay on target. So everybody with a browser should hit this, and every other device in the home network, including router 1 and switch 1 and switch 2, they should be able to ping thekeithbarker.com. So they don't have browsers, so they can't actually go to a web page, but they should be able to ping the server at thekeithbarker.com, which is this guy right here. All right, so that's our objective. So if you're watching this in the live premiere that's today, please continue watching. But if you're watching this sometime after as a recording later, I would encourage you to pause here, download this lab, and actually work on the solution to get all these devices to be able to ping and or reach the web page here on the internet server in Packet Tracer. If you are if your skills are up there already, where you've mastered most of the basic CCNA concepts and you'd like to take it to the next level, the challenge would be this. Don't download the lab. Build this topology with a wireless LAN controller, an access point associated with it, 3 or 4 VLANs, put the servers in different VLANs and devices in different VLANs, set up DHCP, set up the VLAN interfaces on the multi-layer switch, set up routing. It's a great rehearsal, great practice. And you can also set up this home router and give the internet access as well. So that's for those people who have graduated beyond CCNA and you want some really good practice. This was a really good exercise. Take it from a double CCIE. This was a great refresher on all those technologies. All right, so having said that, let me go ahead and let's tackle this. So what we're going to do is we are going to take this network and we're going to work from a client somewhere on the network and work our way out. And that's because that's the starting point. Also, one of my biggest challenges in working with production networks, and it's still a challenge today, is when I walk into a brand new network and I've never seen it. I don't know their subnetting. Maybe they've given me a list or something, but I haven't really felt comfortable with it yet. Like, oh, I know where that is. And subnet 32, that's over here. So on a brand new network, we're not going to know, like the back of our hand, all the details of where stuff is. And this Packet Tracer Lab is going to be the same for it. It's like, well, what VLAN is this in? And what's the default gateway? And who is the default gateway? And does that work? So this is really good practice in discovery of where devices are, how they're connected, and making notes as you go through could be a lifesaver. Because as you document, see, for me, when I was younger, when I was like 25, I was like, okay, I could remember things like, and now as networks are more complex and we have underlay networks, which is the physical infrastructure and how things are connected, then we have overlay networks, logical networks, which you'll get to with software-defined networking and DMVPNs and other things. It's important to document where the heck stuff is, because if you think, oh, well, that was that IP address and we get it wrong, or we don't remember it correctly, we could be just chasing our own tails for a long time. Okay, so as you work on this, I would get a piece of paper or pad or whatever else you want to do, and jot out the details as you go through it. That is a significant help. And I remember there was an airplane pilot I met about 15 years ago, and I forget what airline he worked for, but he had a new flip phone 15 years ago, right? Smartphones weren't that smart then. He had a flip phone, and he was using the type where you have to type. And if you have to type a word, you have to press a certain character, like a certain number of times to get the letter you wanted. Anyway, he was taking incredibly long to do it, and he's like, you know what that's like? You know what that's like? You've seen me do troubleshooting sometimes. It's like, well, come on, just get to it. Well, it's important. And as he went through it, I said, you want me to do it for you? I'll take the phone, I'll just do it for you. And he's like, no, I got this, because it's important to take the time, measure twice, cut once, and get the habits and the practice. That's why it's also important to do Packet Tracer labs and other labs to get that practice. Slow, sure, getting the practice, and your skills will get better and better and better. So just like the airplane pilot who was learning 15 years ago how to make words appear on his phone by using the keypad and the numbers by multiple presses, we also had to take just enough time to document in a network like this what's where, why it's there, what VLAN it's in, what's the default gateway, and document that. That way, as we continue troubleshooting, we can look back and say, no, that works. I verified that already. All right, I'm getting off my soapbox. Let's go to the lab, and now let's do the walkthrough of getting full connectivity from everything in our home lab through our home network up to the internet, and all done in little Packet Tracer bubble. Okay, and here we go. Let's first of all start with this wireless client right here. So this wireless client, and I will bring up an interface for that. Let me just verify that we can all see that. Okay, so this wireless client is associated with an access point, and that access point has a relationship and is being managed by this wireless LAN controller. You can check all that out separately, but I have that little radio frequency there, and we can just go to the desktop and go to a command prompt and do an IP config. And look at that. He's got an IP address. He's in VLAN 3. That's the IP addressing I used. 172.16.3, that third octet is matches the VLAN number. He's got an IP address. He's got a default gateway. Let's see if he has a DNS server. IP config /all. And he does. All right, right there. So he's got a DNS server of 23.1.2.2, which is, in measurable terms, that's this guy right here. That's this internet server. So I guess let's start off by, where do we start? Well, we could open a browser and just say, does it work? That's not a bad idea. When a customer says, hey, this doesn't work, please, could you verify, could you demonstrate that so I can see it? Great. So the goal is to be able to open a browser and go to thekeithbarker.com. And sure enough, doesn't look like it's working. All right, and then we could close that and go to a command prompt, and maybe that's an application layer problem. Maybe the web service isn't running, or there's an access control list filtering somewhere. But we could also do a ping to thekeithbarker.com. Now, the reason that this is so darn good is because this is doing name resolution. I mean, if we do a ping and it comes back with the IP address, but the ping doesn't work, that means DNS is working, but our IP connectivity isn't working. But it looks like here we're not getting a response from our DNS server. So let's do a Control-C to stop that. And we can also use NS lookup. This is a good tool, not just in virtual land here, but also in the real world. NS lookup, that's showing us our DNS server is 23.1.2.2. And this is called interactive mode for NS lookup. And let's do thekeithbarker.com. And I pressed enter, it's just not flying. So let's do an exit out of NS lookup. Let's do a ping to 23.1.2.2. Okay, destination host unreachable. That's great. That's somebody telling us with an ICMP message, usually, that, hey, you can't get there from here. Let's see who told us that. Let's do a trace. Trace RT in Windows is how you do that. And we'll go to 23.1.2.2. So this is showing us our hops through the network. So we're making it to 172.16.3.1, which is good. And that's our default gateway based on the show output of ipconfig. And, oh, yeah, this doesn't look good. So our yeah, every hop is showing 172.16.3.1. That's not good. I'm going to do a Control-C there. So our default gateway, we're forwarding a packet to our default gateway. That's 172.16.3.1. That's from the output right here. That's our default gateway. Now, in this topology, who the heck is our default gateway? And the answer to that is this multi-layer switch here is our default gateway. So if we can also hover on that guy, the multi-layer switch. See how he has the IP address of 172.16.3.1. And we can also just go to the interface and take a look. Great practice. I strongly encourage you to practice this and get the hands on and do the troubleshooting. And if you're brand new to this whole world of Cisco, you can do this. Just take one step at a time, get a little better every day, and you can absolutely do all of this. So let's do a show IP route. And here's the problem. I'm doing a show IP route of the IP routing table. And what happens is when the PC sends a packet with the destination IP address of 23.1.2.2, which we tried and it failed, this router, this multi-layer switch acting as a layer 3 router based on the output of the routing table says, okay, 23.1.2.2, I have nothing in my routing table that matches any of those bits, at least not the first network, the network portion. And so it basically says I can't get there from here. So the problem is switch 1 does not know how to forward it. So how do we solve that? We have a couple options. We could put a default gateway or a default route on switch 1 that says, hey, forward it to R1. But the other problem is, what about R1? Does he know how to forward it? I would say let's go to R1 and make sure R1 knows how to forward a packet to 23.1.2.2. And to do that, we're going to look at the routing table on R1. And on R1, we'll just do a show IP route. And if we look at the routing table, they're sorted numerically these days. When I was first starting in networking with Cisco, they weren't numeric. It's like, whoa. Good. So you can pipe the output and filter the output. That's all true too. But or we could do a show IP route for 23. Yep. So doesn't know about 23. So it doesn't know how to get to the 23 anything, and that's because R1 does not know that it should forward a packet to the default gateway on your home network of 192.168.1.1. So let's add a static route that says, hey, if you don't know what to do, a static default route, send it up to your home router. So we'll do that. So we'll do a config t, IP route, 0000. That's how you spell default route for IPv4 in Cisco CLI. And the next hop is 192.168.1.1. All right, there we go. And let's do a show IP route just to verify our work. Why it's at the bottom, I do not know. Anyway, normally it's going to be at the top. That's okay. So there's our static route. And let's try to ping the next hop. Ping 192.168.1.1. Okay, good. So the first packet timed out with the ARP, didn't go because of the ARP, and we're good. So we have a default route. It is the home network default gateway, and we can ping it. So if we were to, here's the play-by-play on this. If we sent a packet out to the internet, we would forward it to our default gateway because we don't have a more explicit route. It would then do PAT, which is what the home routers are doing, port address translation, and it would basically, it's like NAT with overload. It would translate our source IP address using whatever it has on the outside here, forward it, and then when the reply comes back, it would untranslate it. So the internet doesn't even know we have a 192.168.1 address. It just thinks we came from whatever IP address our home router or a device in the service provider path converted us to. So let's test that real quick. And we'll go back to R1, and let's do a trace to 23.1.2.2, which is the server on the internet. Okay, I'm going to do a Control C to stop that madness. Or this is a Cisco router, so I'm not going to do a Control C. I'm going to do a Control Shift 6. I'm going to do that a couple times. Control Shift 6. Oh, come on now. All right, packet tracer. Come on, let go. All right, so it's not letting go. What we can do is down here on packet tracer, there's this thing called time. I had, I think it was Trevor who showed me this, and it was really cool. So you can just fast forward time. Time keeps on slipping, and so you just forward the time, and then you go back to the router, and it's timed out. Hit its max of 30, and you have to sit there and watch it. Oh, so Trevor, thank you very much. Appreciate that. Another fellow Las Vegan. I appreciate that very much. Okay. What's going on here? Let's do a ping to 23.1.2.2. Okay, so our ping works. All right. So with a trace, we're using ICMP and reachable messages from each hop in the path coming back to us to let us know. So the trace doesn't work, and that's okay. Firewalls will also cause that to happen occasionally too. But we do have reachability from R1 to this server, which is fine by me. So we can reach it. So let's go ahead and identify why switch. So why can't this client reach it? Well, the problem that we have, and I'm going to speed this up a little bit to not belabor the point, but the problem we have is that R1 now has a default route to go out to the internet. So to here, then here, but the client who's using the multi-layer switch as the default gateway, it's fine. Chick. However, the switch does not know about a default route to get out to the internet. So switch 1 needs a default route. We can do that two ways. We can statically have a default route and say, dear Mr. Switch, your default route points to the next hop of R1, which is 172.16.1.11, which it is, or we could advertise a default route with a routing protocol. And if these guys are all running OSPF, so we could just have R1 default information originate its default route into OSPF, and then switch 1 would have it. So just to verify that, we'll go to switch 1. There's no default route here. And we'll go to router 1 and config t, do show IP protocols. Just want to verify what our process is. Router OSPF 1, and we'll go into that routing process. And we'll do a default information originate. And then if R1 has a static default route, it will originate that or impose that into OSPF so that every other OSPF router will learn about a default route. So if we go back to switch 1 and show IP route, there it is. There's the default route learned with the next hop of 172.16.1.11, which is R1. Great. So now R1 can get to the internet. Can this PC? We'll go back to this PC. We'll do a ping to 23.1.2.2. All right, we'll do a control C. That's not flying. Let's do a trace out to that. Okay, so that's better progress. So we're making it to the default gateway, which is on the multi-layer switch. The next hop is .11, which is great. It is actually making it to our home router, but unfortunately the home router, when it gets that, I'll just do a control C here. When the home router gets that, it says, I would love to send an ICMP unreachable, or because with the trace route, it uses TTL, time to live. And so this router, when it sees the TTL expiring, is supposed to send a message back, or here's switch 1, but this router does not know how to reach the 172.16.1 network where this guy is coming from. It just doesn't know. It's just not in the routing table. So it has a default route going that way, but it doesn't know how to get here. So a couple options that came up in the last video we did with connecting a home lab to the internet, and that was, well, couldn't we just put a static route here on the home router and say, dear Mr. Home Router, to get to 172.16 anything, use R1 as your next hop? And the answer is, great idea. If your router supports that, rock on. But if it doesn't support it, then you might be in trouble. So if we go to the home router in Packet Tracer, go to the GUI, I don't think that this flavor of a home router supports a static route. So you could look through here, and if it does support it, you could set it up. But in the event that it doesn't, we're going to have to choose another alternative, and that other alternative is to do NAT. And it's going to go like this. We're going to take R1 and make this the NAT outside. And we'll make gig 00 on R1, NAT outside, gig 0/1 NAT inside. So it gets fun. And then we'll create an access control list. Now, access control lists are used for lots of purposes. Sometimes they're used for filtering traffic. Sometimes they're used to identify traffic, including when we're going to use NAT. And we're going to use an access control list in conjunction with NAT rules to say, hey, any traffic coming from 172.16 anything will be okay, will be a match. We'll make that access list 1. And if traffic is going through the router 1, being routed this way, from an inside interface to an outside interface, let's go ahead and translate the source addresses to this outside interface address, gig 00. And then from the router's perspective, the home router, it just thinks it's getting a whole bunch of traffic that's coming from whatever this interface address is, and it routes out to the internet. It does its own version of PAT right there, and then the reply traffic can come back. So let's do that next. And this is very similar to what we did with the physical gear when we were connecting it to the internet previously. This is just simulated here in Packet Tracer. So let's do that. Let's go ahead on R1, and let's do a show access list. It's always important to start by looking at seeing what you have. So if you have an access list already in place and you start adding lines, it's just going to append as opposed to being brand new. So no access list yet. Let's create access list 1, permit, and we'll do 172.16.0.0, and then a wildcard bits that say we don't care about the last 2 octets. That's important, because we could have clients in subnet 2 or 3 or 4, with the third octet being a 2 or 3 or 4. Well, I want to include all of them. So there's our access control list that we're going to use as part of NAT. Then IP NAT inside source list 1. And we are going to specify interface, and it's going to be on the router. Let me scooch over here. It's going to be gig 00. Oh, and I need to do overload. Otherwise, we're not going to have PAT. So I want to do overload so that I can have thousands of IP addresses all mapped to that single outside address. Great. And then we need to tell the interfaces that they are inside or outside respectively. Interface gig 00, IP NAT outside, interface gig 0/1, IP NAT inside. Awesome. And let's verify that this switch can actually get to the internet now. That's a great intermediate step. So he's got a default route. Let's do a ping to 23.1.2.2. All right, so if we trace that, trace, not too happy with the home router. Anyway, that packet is being routed from switch 1 to R1, which is the default route. R1's forwarding it to the home router, which is its static default route. The router is then making a routing decision and doing pat out to the internet, and then the server is responding back. Okay, so let's verify a client can get there. Here's the wireless client on the inside. Let's do a trace. Look at that. All right, from the client, default gateway, and then .11 is the router 1 interface, and then that's our home router, and then that's the actual web server. Fantastic. Well, let's try DNS. ipconfig /all. So our DNS server, this is looking really good. So our DNS server is 23.1.2.2, and we just verified we can reach that device. Let's do ns lookup for the keithbarker.com. It resolved it right there to 23.1.2.2, which is that internet web server. Let's just go for, we'll close that window, and let's go for a browser. Okay, okay, so that works. And again, this website, thank you to Dan for creating this for me. So that's my master playlist on YouTube. Just go to basically it's called see here, ogit.online/sloth, to remind ourselves slow and steady wins the race. And then here's also a link for the Discord server, which you're also welcome to join. Great, and I'll put links for all that down below as well. Okay, so that works. Now, the task was to make sure all clients with browsers, all devices could get there. Let's go to the lab server. We'll open up a browser, desktop, browser, thekeithbarker.com. Okay, that works. That's all okay, and then PC2, we'll try that too. Desktop, desktop, and all right, and let's just verify it works here. Thekeithbarker.com. Okay, great. That's all of our browsers. Let's make sure our switches can also get there. So ping thekeithbarker.com. Okay, so that's because I have no IP domain lookup. So let's fix that. And we can already ping the IP address. We know we can get there. Let's do a config t and IP domain lookup at my own peril. DOMAIN -lookup. And then IP name server is 23.1.2.2. And then ping thekeithbarker.com. All right, that works. Fantastic. And we could do the same exact treatment for R1 if we wanted to be able to ping by name, enable domain lookup, specify the name server of 23.1.2.2, and let's just check on switch 2 and we'll be done. So here's switch 2. Let's make sure it has a management interface. Show IP interface brief. If it doesn't, we're in trouble. Okay, it does. And let's just verify we can ping the default gateway on that VLAN 1, which is, well, R1's interface on VLAN 1. 172.16.1.11. Okay, good. The first one timed out because we had the ARP request. Great. So we can reach, that's switch 2 accessing or reaching R1 on the VLAN 1 network. So what were we trying to do? Oh yeah, let's do a config t, IP domain lookup. And then I gotta be careful about typos after this point, so I don't have a timeout and telnet. So IP domain lookup and IP name server is 23.1.2.2. Great. And ping. Okay, I think we're done. Ping thekeithbarker.com. All right. Well, this is saying I'm trying to resolve the name thekeithbarker.com to an IP address. I'm trying to use the DNS server at 23.1.2.2. I'm not having any luck, so I'm going to do a control. I'm going to hit the fast forward button here a bunch of times and let him time out. I'm not going to wait for him. All right. Let's try to ping the IP address of the DNS server. Okay, Control Shift 6. Oh, okay, it's only 5 pings. Or we can also fast forward here. By the way, Trevor, thanks for that tip of being able to fast forward time. It's like that movie Remote, I think, where he wanted to avoid parts of his life that were boring, he thought, so he had a remote he could fast forward, and they realized he missed most of his life by fast forwarding. All right, but this is Packet Tracer. We have things to do. Okay, so we don't have, let's do a trace. Let's do show IP route. Oh, this is a layer 2 switch. So the default gateway should be on R1 of 172.16.1.11 is the default gateway it should be using. Let's do a show. It's not a router. Let's just take a look. Show IP route. Now show it. Let's do a show run pipe, and we'll include gate. So any output in the running config that has the word gate in it. That explains it. We don't have a default gateway set up. Config T IP default gateway is 172.16.1. Oh, come on, Keith. .1.11 and up arrow key a couple times. Just want to verify that it really is in the routing in the config. Now we'll do a ping to 23.1.2.2. All right, now it's working. Okay, we said everybody needs connectivity, so let's verify this. We'll do a ping to thekeithbarker.com. All right, we are good to go. I think that is everything. So our wireless client connected, our wired client connected, our lab server connected, the switch is connected, the router connected, all being translated. So this is a simulation of setting up your home lab to have isolation, because if you have one flat network at your house, you don't want to put all your networking gear there, because it's going to interfere with your PlayStation or your Xbox or your your Amazon Echoes, I'll say that quietly, or your Google Home devices and your Internet of Things. So you want to keep it separate so that all that stuff that goes on is not in the same broadcast domain, not the same layer 2 domain as your home network. So here we've taken a look at how you can build your own separate network and then do NAT to have all those devices with proper routing in place go through the edge router, in our case it was R1, to make them all look like they came from the IP address of R1, and then your home router is further going to be able to go ahead and translate that as it goes out to the internet, and the replies come back. They'll be untranslated at the home router and untranslated at R1 for the rest of your internal network. All right, that took a little longer than I thought. I had a lot of fun. If you found any value in this video, I am so glad. That's the reason I did it. I want you to practice and get better and better and better with the fundamentals of networking. This was a great lab to do that. If you got some value out of it, hit the thumbs up button to let people know you got value out of it. If you haven't already, please click on subscribe. There are thousands and thousands of new CCNA students who are learning CCNA concepts all the time. CCNA is one step in a bigger picture, and it's an important step for the fundamentals. And we would like to be a big part of that step for you in helping you get better and better and better. Also, many of you know already, but if you don't, my full-time gig is at cbtnuggets.com. And if you're looking for a soup to dessert end-to-end CCNA training from a commercial site, the playlist CCNA 200-301 at CBT Nuggets, which is a paid subscription thing, it's awesome. It's Network Chuck, it's Jeremy Chara, it's myself, from soup to dessert, the entire blueprint in order. So if you want something structured that like boom, 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 covering every single blueprint item, that is one great option that I'd recommend. We also have a free 7-day trial that you can check out there as well to see if it suits you. All right, so thanks for joining me for this lab, this Packet Tracer lab, and I'll see you in a future video, and I wish you the best of success in all of your studies for CCNA and beyond. Thanks, everybody.